Hello everyone! Right, so let me quickly get this video done. So this is a video on calculating the area of a triangle, but with a twist, ladies and gentlemen. We're calculating the area of a triangle that is on a coordinate plane. So have a look at this diagram here. So the diagram below shows a triangle with vertices 0, 0, and x1 and x1, y1, and x2, y2. So vertices are just points, yeah? So the vertices are here and here. So the points are 0, 0, x1, y1, and x2, y2. The area of this triangle is given by this formula here. A half times the absolute value of x1 times y1 minus x2 minus y2. So first of all, what's absolute value? So if I see two lines like this, now someone brought up, it's a very good point, sometimes this is used to indicate distance in coordinate geometry, but in this instance for this formula, it indicates absolute value. So absolute value. So what is absolute value? It just means whatever is inside that bracket, I make it positive. So bracket or lines, I should say. So if I have the absolute value of minus 2, that's going to be positive 2. The absolute value of minus 4, that's going to be plus 4. You know? Same as if I have the absolute value of 2, that's going to be 2. Yeah? The absolute value of minus 3/4 is going to be 3/4. So I just make anything inside my absolute value bracket positive, basically, is what I do. So let's have a look at some examples first. Now, just to make a note first, this formula only works is when one of the points is the origin, so 0, 0, right? And then I have two other points. So this only works if one of my points is at the origin, and I'm going to show you what we're going to do if we have a point where none are at the origin. So first of all, I have this question here. Find the area of the triangle with the vertices 0, 0, minus 2, 1, and 3, 4. So again, the vertices are just points. So let me just plot these. So that's going to be 1, 2, 3, 4. 1, 2, 3, 4. Minus 1, minus 2, 3, minus 1, minus 2, minus 3. Right. So I'm going to plot these points down. So 0, 0. There's my first point. Here. Then can I change the color? Then minus 2, 1. So I go to x is minus 2, then go up to 1. So there's my second point. And then my third point is at 3, 4. So x is 3, y is 4. So that's going to go up here. So I'm able now to calculate the area of this triangle given here. I'm able to calculate the area of this triangle with the formula above me here. So a half times the absolute value of x1, y1 minus x2, y2. So I ignore now. So one of my points is at 0, 0. So I just kind of ignore that for the time being. I label my other 2 points x1, y1. So that's x1, y1, x2, y2. Then my formula is so a half times the absolute value of x1 times y2, so be minus 2 times 4, minus x2, which is 3, times y1, which is 1, and close my absolute value. So I have a half absolute value of minus 8, minus 3 times 1, which is going to be minus 3, a half times minus 11. So it would be a half times the absolute value. A half times the absolute value of minus 11. So that's going to go to a half times 11, which is just 11 over 2, basically. Yeah, 11 over 2. And that's it. That's my answer for the area. So 11 over 2 units squared. So let me look at another example here. So here's another example. Find the area of the triangle with the vertices 2, 4, minus 3, 1, 3, minus 5. So let me plot this one out quickly. So 1, 2, 3, 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. So 2, 4. So 2, 4 is going to go there. Minus 3, 1. So minus 3, 1 is going to go here. And then 3 minus 5, 3 minus 5. So this is, let me kind of change the color here. So this is my triangle here. Now, problem is I can't use my formula to find the area of that triangle yet because I need one of them points to be at 0, 0. So I need to do a bit of transformation here. I need to transform or actually move this triangle. So what I'm going to do is I'm going to pick one of these points. So I'm just going to pick this 2, 4. I'm just going to pick the 2, 4. And I'm going to move that to 0, 0. So what am I doing here? So I'm making 2, 4. And I'm transforming that to 0, 0. So what's happening here? What's happening? So I'm moving a 2 to 0. So what's happening? I'm subtracting 2. I'm subtracting 2 from my x value. Then I'm getting from 4 to 0. How am I doing that? I'm subtracting 4 from my y value. So my transformation now is my transformation is going to be minus 2 on the x and minusing 4 on the y values. And I'm going to apply that now to my other points. So if I'm applying the transformation onto minus 3, 1, so I'm applying that transformation, so I'm subtracting 2 from the x value, so that'd be minus 3 minus 2, which is minus 5. Then I'm subtracting 4 for my y value, so that'd be 1 minus 4, which is minus 3. And that's my transformed point. Same here, 3 minus 5. My transformed point is going to be 3 minus 2, which is 1. Then minus 5 minus 4 is minus 9. So there's my transformed points there. So if I can hopefully quickly draw this out nicely. Change the view on this. Anyway, okay, I'm just going to roughly estimate this. You shouldn't be doing it, but I am. So 1, 2, 3, 4, 5, 6, 7. Yeah. Then minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9. So minus 9 is down here. So 1, 2, 3, 4, 5. Should have really done this out before I started the video, but oh well. I'm minus 1, minus 2, minus 3, minus 4. Now, yours will be a bit better than mine now because you'll be all organised and have your boxes. Right, so let's start leaving my points. So 0, 0, that's my first point there. Then minus 5, minus 3, so go to minus 5, go down to minus 3. So that's my second point there. And then 1 minus 9, 1 minus 9 is down here. So if you looky here, if I kind of compare the two shapes now, so I moved this point, right, down to my origin here. And you see how, now again, I do have to reiterate, I didn't probably do this to scale, but to see how it's basically the same shape but shifted down. So I moved that down. So now my new vertices points are, so 0, 0, minus 5, minus 3, and 1 minus 9. So now I'm going to use my formula. So a half times the absolute value of x1, y2 minus x2, y1. So that's x1, y1, x2, y2. So it'd be a half times, so x1 is minus 5 times y2, which is minus 9, minus x2 minus x1. So x2 times y1. So it'd be 1 times minus 3. So it'd be a half. Minus 5 times minus 9 is 45. Then minus 1 times minus 3, which is plus 3. So therefore, I have a half times the absolute value of 48, which is just a half times 48, because the absolute value of 48 is 48. So therefore, my answer is 24 units squared. Right? And that's how you calculate the area of a triangle in coordinate geometry. And I hope this was some use to you guys. So just to remember, if I do not have a point that it lies at the origin of 0, 0, I have to move 1 point to 0, 0, record the transformation, apply that transformation to the other point, and then I can use my formula up here. Right, okay, 10 minutes, cutting it short, hopefully. So, hope this helped, and I'll catch you on the flip side. Peace.